Hi there and welcome to another video with Hegarty Maths. It's Mr. Hegarty here, and in this video we're doing our third and final video on indices with algebraic expressions. I'm not going to lie to you, it's going to get pretty tricky in this video, so at the outset I'm going to tell you exactly the skills you need to be ready to tackle the stuff in this video. Firstly, you need to know your indices rules, the 9 of them. We learnt them in the number strand. Go back there and be familiar with them if you're not already. Also, I'd like you to have watched indices with algebraic expressions 1 and 2 and got 100% on your test before trying this. Next, I need you to be super good at fractions, multiplying fractions and whole numbers, or fractions, adding or subtracting fractions. So I need you to be really good at that. Pause the video now, prove to me and yourself that you can do the following 4 questions before moving on. So let's have a look at the answers. Hopefully you could get the following answers: 4, 9, a sixth, and 1 2/3. Okay, and I've shown the methods how to do it. I'm not going to go into it in this video. All I'm going to say is if you don't know those, please go back to the fractions section, look at how to multiply fractions and whole numbers and add and subtract fractions before we go on to this video, as you're going to need to be able to do that pretty easily to cope in this video. But if you know your rules of indices and you know your fractions, we can do this. So let's get on and try some really tricky questions. Simplify the following, leaving your answer in index form. So I've got this expression multiplied by this expression. Because multiplication is associative and commutative, I can multiply the numbers first. Now I can go off here and in my head do 6 multiplied by 2/3, which is going to be 12 over 3, which is 4. So 6 multiplied by 2/3 gives me 4. A to the power of 4 multiplied by a to the power of, we should have put a 1 in there, 1 like that, is going to give me a to the power of 5. So I can write that as my next part of my term. And b to the power of 5 multiplied by b cubed is b to the power of 5 add 3, which is 8. Done. Now the next one's a division. I always like to write my division with like a fraction. So I'm going to write that as 3x to the power of 4 y cubed, and I'm going to say that's divided by 1/5 x to the power of 1. I'm going to write y squared. Now let's do the numbers divided by each other first. Okay, so let's do 3 divided by 1/5. Now we may have to go off here and do separate working. 3 divided by 1/5, that's like 3 over 1 divided by 1/5. Dividing by a fraction is the same as multiplying by its reciprocal, so it's like doing that, and we get the answer 15. So we could say that 3 divided by 1/5 is 15. X to the power of 4 divided by x to the power of 1, okay, we can say is x to the power of 3, or we could cancel one of the x's, that's the way you could look at it, so that's x cubed. And y squared and y to the power of 3, the highest common factor is y squared, which we could cancel, and it would leave us with 1y on top. And we're done. Okay, pause the video and have a go at this one. Really tricky, this one. Okay, we've got an expression cubed divided by another expression squared. Write it in fraction form. I think it's easiest like that. 5pq squared all cubed divided by 10pq all squared. Now before we try and do the division, we should expand or simplify the numerator and denominator. Let's try and do that. We can do that by saying 5 cubed, then p cubed, so we'd write p cubed, and then q squared cubed. We better write the q squared with a bracket around it to remind us to cube it. And then we're dividing that by the 10 gets squared, the p gets squared, and the q gets squared. Now we need to tidy up the numerator and denominator. 5 cubed is 125. We've got p cubed, and q squared all cubed is q to the power of 6. And we're dividing that by 10 squared is 100. We've got a p squared and we've got a q squared. Now we need to simplify this. Well, simplify the number part first. The highest common factor of 100 and 125 is 25. Divide the top and bottom by 25. I would get 5 on the top and I would get a 4 on the bottom. The highest common factor of p squared and p cubed is p squared, so I divide the top and bottom by p squared, or cancel p squareds, leaves me with a single p on the top, p to the power of 1. And q squared divided by q to the power of 6 is q to the power of 4 left on top. So the answer here is 5. We can write that as 5p to the 1, q to the 4, all over 4. Or I could write that with the number in front. I could think of that as 5 over 4, like this, p to the 1, q to the 4. Either of those is acceptable. And we're done. Next one. Express the following in the form x to the power of n, where n is some number. Well, you should know the square root of x. Well, that's written as x to the power of a half. What about this? Well, this thing here is already x squared. We're multiplying it by x to the power of half. And when I multiply and the base number is the same, I can add the powers. So this is going to be x to the power of 2.5. And I could write that as an improper fraction if I want. I could say that's x to the 5 over 2. Both are allowed. What about this one here? Well, this is x cubed square rooted. So that whole thing is to the power of a half. And by the power of the power rule, this is going to be x to the 3 multiplied by a half, which you should know is x to the 3 over 2. And we're done. Next one. Pause and try and write each of these in the form x to the power of something. Well, 1 over the cube root of x, that must be x to the power of negative something to get the 1 over. And how do you write the cube root? Third. So that's x to the negative third. What about this? We want to write this as a single power of x. This here is x to the half. This here is x to the third. They're multiplying together. When you're multiplying and the base number is the same, you add the powers. So x to the power of a half plus a third. We need to go away and do that. Make them over a common denominator of 6. This would be 3 6. This would be 2 6. So when we add them together, we get 5 6. X to the power of 5 6. Just to state here, n is negative a third. In this case here, n is 5 6. And the last one, well, let's write each of these in power form. This therefore is x to the power of a quarter divided by x to the power of 1. When you're dividing and the base is the same, you can subtract the powers. So this is going to be x to the quarter take away 1, which is going to be x to the negative 3 quarters. So in this case, n, our power that we were asked to find, is equal to negative 3 quarters. And the last set of questions, we want to write these in the form some number multiplied by x to a power. Right, the first thing is I'm going to realize that 4 over root x, I could think of that as 4 over 1 times 1 over root x. By multiplying fractions, I can think of it like that. Now 4 over 1 is 4, and 1 over root x is x to the negative a half. And hence I've written it in that form where a is 4 and n in this case is negative a half, and we're done. What about this? Well, I can think of this as 1 over 2 multiplied by 1 over x. And I could say that's a half x to the negative 1, because 1 over x is x to the power of negative 1. So in this case, my a is a half and my n is negative 1. What about this? Well, I could think of this, the 3 and the 4, as a separate fraction. I could think of this as 3 quarters multiplied by 1 over x cubed. So this is 3 quarters multiplied by x to the negative 3. So in this case, my a is 3 quarters and my n is negative 3. And the last one, 1 over 3x all squared. Well, let's work out the denominator. There's something to work out there. 1 over 3x squared is 3x times 3x, which is 9x squared. I could think of that as 1/9 multiplied by 1 over x squared. So I could write that as 1/9 x to the negative 2. So in this case, my a is a 9th and my n is negative 2. And that's it for this video. About as complicated as it gets. Thanks for watching.